to my video on similar figures where we are going to find the missing side. So remember, similar figures have same shape but different size. And remember, their corresponding angles are the same. And similar figures are also proportional. So we're going to look at setting up proportions today to determine similar figures, and also using proportions to find the missing side. So how can I determine if figures are similar? I can compare ratios of corresponding sides. In other words, comparing the first figure to the second figure. So let's call this first and second. Okay, so remember, corresponding side is the same side on the other shape. So I'm going to circle the 6, and I'm going to circle its corresponding side over here, and I'm going to write a ratio, 6/3. Okay, and then we're going to write the ratio of the bottom of each triangle. So we're going to say 10 and 5, so we're going to say 10/5. Now notice what I did here. I did first side over second side, first bottom over second bottom. And notice I'm consistent. I can't switch it around. If I put this one over this one, then I have to put this one over this one. Have to stay consistent with my proportion. So we can use cross products to see if they're similar. So 6 times 5 is 30. And 10 times 3 is 30. So notice that the cross products are what? Equal. So it says, what do you notice about the cross products? They are equal. Now, I could have also set this up as 10/5 equals 6/3. There are so many different ways of doing this. I could have also done second side over first side and second bottom over first bottom, and they still would have come out exactly the same. They still would be similar because their ratios would be equivalent. Okay, so is there another way to determine if they are similar rather than using corresponding sides? And the answer is yes, there is. So look here. This is the same picture we had above, but watch. Now I'm going to do side over bottom, so 6/10 equals, I'm going to box this in, 3/5. So what I'm doing here is first side over first bottom, second side over second bottom. And watch what happens. 6 times 5 is 30, and 3 times 10 is 30. So there are many, many ways to set up a proportion. I could go short side over long side, short side over long side, or I can go short first over short second, and bottom first over bottom second. There are so many different ways to set up a proportion as long as you stay consistent. When triangles are similar, we write ABC, and remember this is the similar, it looks like a worm, to triangle DEF. In a similar figure, the ratio of corresponding sides will be equal. And one other thing I want you to notice too is this shape is half the size of this shape. And if it's half the size, then it stayed proportional because I took half of each side, or half of each length, to get this figure. Half of 6 is 3, half of 10 is 5. Okay, so it stayed proportional. Now, look at the bottom. Are these quadrilaterals similar? Prove your answer. So let's just do, for this one, I'm going to put first over second figure. So this is the first side over the second side, so 10/8. And first bottom over second bottom, 4 over 2. Okay, let's do the cross products. 10 times 2 is 20, and 4 times 8 is 32. So 20 does not equal 32, therefore they're not similar. And some of you are probably going, I could already tell they weren't similar. But notice it said prove your answer. And one way of proving your answer is by setting up a proportion. And notice, look here, half of 4 is 2, but half of 10 is not 8. If this had been 5, then they would have been similar. Okay, and also, let me point out one thing. I didn't need to do first figure over second figure. I could have done side over bottom, side over bottom. Okay. Well, actually, this is the top of the trapezoid. It's just upside down. Okay, so let's look at how do we find a missing side. Okay. Previously, we were proving if they're similar, okay, by using cross products. Now, we're going to also use a proportion to find the missing side. So it says ABDC is similar to JKML. Notice AB corresponds to JK. So there's the top of the rectangle, top of the smaller rectangle. And BD, side of the big rectangle, corresponds to KM, side of the small rectangle. So now what we're going to do is we're going to set up two different proportions, and hopefully you'll notice something. Okay, so we are going to do the corresponding sides proportion first, where it says AB over JK. So my screen's covered up, so look on your paper. AB is 25 and JK is our X. So I'm going to put 25 over X. And then we have BD over KM. So BD here is 12 and KM is 6. So we're going to put 12 over 6, just like we did previously. But now, since we have an X value, we can find out what it is. So we're going to do our cross products. And remember, we did this earlier in the year. 12 times X is 12X. And 25 times 6 is 150. Now, remember, we're solving for X, so I need to do the opposite of multiplication, which is division. 12 divided by 12 is a 1 in disguise. And 150 divided by 12 is 12 and 5/10. Okay, now, remember on the previous page when we were proving similar, we said we don't always have to use the corresponding sides. So I'm going to show you how we could do long side over short side. So look at your note sheet, and the long side of the first figure is 25, and the short side of the big figure is 12. So I'm going to do 25 over 12. Now, because I did long side over short side over here, I have to do long over short. So I'm going to do X over 6. Now, we're not going to solve this because what do you notice? It's going to be exactly the same. Check this out. 12 times X is 12X. 25 times 6 is 150. And then I would get the same answer. So we're not going to solve it again. But you can tell it has the same answer because it has the same numbers diagonal to the X. The 12 is diagonal to the X, just like over here. And the 25 is diagonal to the 6. So they are an equivalent proportion. Okay, let's look at example number 2. It says ABC is similar to DEF. What is the length of DF? So the first thing I want to do is put a letter here, and I'm just going to use X. So now, when I set up a proportion, I have to make sure my X value is in the proportion. Okay, so we're going to do first bottom over second bottom, so 6 over X. And we're going to do first side over second side, so that would be 8 over 4. Okay, now we're going to solve the proportion to find the missing values. So 8 times x is 8x. 6 times 4 is 24. And what's the opposite of multiplication? Good, it's division, so we're going to divide both sides by 8. 8 divided by 8 is a 1 in disguise. And 24 divided by 8 is what? 3. And our label is meters, so we're going to put 3m. Okay, now let's look at this for a second because that wasn't the only thing I could have done. Okay, I could do 6 over 8, and then I could have done x over 4, bottom over side, bottom over side. I could have also done this side over this side, so I could have done 4 over 8, x over 6. That would still stay consistent. Okay, so there are many ways to set this up. Now, here's a way you can check to make sure your answer is true. Now look, this figure is smaller than this figure, so this x has to be smaller than 6. So if I get an answer larger than 6, then I know that doesn't make sense and I set up my proportion incorrectly. Okay, and I also know that the bottom is smaller than the side, so I know it has to be less than 4. Okay. All right, let's move on to the next one. It says, if triangle XYZ is similar to triangle STU, then the corresponding angles are congruent because they're similar. What is the length of XY in centimeters? So I need to find where XY is, which is right here, and I'm going to put in X. Okay? And remember, I could line up the letters to see which sides go together, but I know that this is the bottom here, it's just flipped upside down, so I know the 3 goes with the 9, I know the 3.5 goes with the X, and the 1 doesn't have anything to match up with. So guess what that means? I can't use the 1 because I can't have 2 missing values in my proportion, okay? And we're looking for the X, so we got to make sure that's in my proportion. So I can't use the 1 because here's its corresponding side and there's no measurement there. I don't know what it is. So what I'm going to do is, and I'm going to set this up a different way. This time I'm not going to do corresponding sides, so I'm going to do diagonal over bottom. So I'm going to do 3.5 over 3. And I'm going to do diagonal over bottom. Notice I have to stay consistent. If I don't stay consistent, it won't give me an answer that makes sense. And remember, the diagonal has to be bigger than the bottom because look, here the diagonal is bigger than the bottom. So if they're similar, then this diagonal is going to be a little bit bigger than the bottom. Okay, so cross products, 3 times x is 3x. 3.5 times 9 is 31 and 5/10. The opposite of multiplication is division, so I've got to get the x by itself by dividing by 3. 3 divided by 3 is a 1 in disguise, so x equals 10 and 5/10 centimeters. Okay, and if we look back to make sure this makes sense, the diagonal is bigger than the bottom. And look, the diagonal is a little bit bigger than the bottom here. So my answer does make sense. If I got something less than 9, then I probably set up my proportion correctly. In fact, I know I set my proportion up correctly. Okay, and the last one. If triangle FOX is similar to triangle FAN, which side of triangle FOX corresponds to FA side? Now, you can do this one of two ways. If you can picture this, this is the smaller triangle. And then let me use a different color here. This is the bigger triangle. So it says what side corresponds with FA? Well, if this is the left side of FA, then this is also the left side of FO. So FA would correspond to FO. So some of you can visualize that, but if you can't, please write, and I want you to write down the strategy anyways. FOX lines up with FAN. So if you look here, which side corresponds to FA? Look what two letters it lines up with. Box this in. It lines up with FO. Okay, that concludes our notes on similar figures and finding the missing side. I hope you have a great day.